It's important to understand and follow 3 safety rules. First, never smoke when working on the fuel system. Keep open flames and sparks away from your workstation. Second, always wear safety glasses when working on or around any vehicle. Third, you must relieve fuel system pressure before hooking up a pressure gauge. There are 2 types of fuel systems used on both Honda and Acura vehicles, return type and returnless type. Both systems contain similar components, but deliver fuel in slightly different ways. Return type fuel supply system has a fuel tank, fuel pump, fuel lines, fuel filter, fuel rail with injectors, pressure regulator, and return line. On a return type fuel system, the pressure regulator is located on the fuel rail. Returnless fuel supply system has the same components as a return type, including a fuel tank, fuel pump, fuel filter, pressure regulator, fuel lines, and fuel rail with injectors. It does not, however, have a fuel return line. On a returnless system, the pressure regulator is located inside the fuel tank. Upon a time, gravity moved the fuel from a vehicle's tank to the carburetor. Today's programmed fuel injection system needs to have a pressurized and constant supply of fuel delivered to the injectors at all times. This supply of constant pressurized fuel is generated by the fuel pump located in the fuel tank. The fuel pump assembly consists of a strainer, pump motor, pump impeller, relief valve, and one-way check valve. The pump is submerged in the fuel and driven electrically to turn an impeller, which will draw fuel through the strainer and develop pressure. The fuel exits through a one-way check valve. The purpose of the check valve is to prevent pressure in the fuel rail from flowing back into the tank when the fuel pump is off. That way, the fuel system will have sufficient pressure when the vehicle is started. The pressure relief valve will open and discharge fuel back into the tank should pressure become excessive. The regulator's function is to keep the fuel at the specified pressure. There are slight differences between the return type regulator and the returnless type regulator. The regulator consists of a housing, valve, diaphragm, and spring. The spring holds the valve closed and allows fuel pressure to build up against the diaphragm. When the fuel pressure overcomes the spring pressure, the valve opens and allows excess fuel to bleed off and return to the fuel tank. On a return type system, the regulator is located near the end of the fuel rail. When the regulator is connected to the intake manifold, vacuum is routed to the pressure regulator to help overcome spring force. This is done to maintain a constant pressure difference between fuel pressure and manifold air pressure. When the throttle is closed, manifold vacuum is high and manifold pressure is low. This results in lower fuel pressure. As the throttle opens, manifold vacuum decreases while manifold pressure increases. This results in higher fuel pressure. Regulators that are connected to the intake air duct are not controlled by engine vacuum. The hose is there to provide unrestricted movement of the regulator diaphragm. These types of regulators operate like returnless regulators, where the ECM-PCM compensates for changes in intake manifold pressure. On a returnless type system, the regulator is located in the fuel tank and is part of the fuel tank unit. There is no return line between the fuel rail and the tank, which keeps the fuel cooler and reduces evaporative emissions. Some Honda and Acura vehicles have a fuel pulsation damper located on the fuel rail. The fuel pressure damper is used to absorb pressure pulses and to reduce noise caused by the injectors opening and closing rapidly. The damper has a diaphragm and calibrated spring. The injector's opening and closing creates a pressure shock wave, which is absorbed by the diaphragm as it compresses the spring. The injector is an electrically operated on-off valve that sprays atomized fuel into the intake port of the cylinder. It is normally closed. The ECM-PCM fully opens the injector for a precise time, measured in milliseconds, in order to deliver the correct amount of fuel to mix with the incoming air. The longer the injector is held open, the more fuel is delivered to the combustion chamber. The fuel injector body is sealed between the intake manifold and the fuel rail. The internal components include an inlet screen, electrical connector, electromagnetic solenoid coil, plunger, and a discharge nozzle designed to produce a cone-shaped pattern. The injector discharge nozzle is designed to optimize fuel atomization by creating extremely fine droplets. Improved atomization enhances engine performance and reduces emissions. Fuel pressure must be within specifications for the ECM-PCM to be able to control the air-fuel ratio accurately. Low fuel pressure can be caused by low or no pump output, restricted strainer, restricted filter, restricted supply line, or a stuck open or weak spring in the regulator. To isolate which component is responsible for the low pressure, first check for any service bulletins or service news articles that apply, and follow the procedures they provide. If there are no bulletins or service news articles, start with the easiest component to test. First, inspect fuel lines between the fuel tank and the fuel rail for any kinks, leaks, or deformation. Then, on a return system, the pressure regulator would be the next place to start. To determine if the pressure regulator is stuck open, relieving too much pressure, pinch close the return line with swivel jaw hose pinching pliers. If pressure rises, the regulator is likely at fault. If the pressure regulator is okay, the fuel filter and strainer, suction filter, should be replaced. Before you replace them, however, you need to make sure that whatever condition caused them to become clogged is no longer present. Otherwise, they may become clogged again soon. If working on a returnless system, replace the pressure regulator and fuel filter. For a customer concern of long crank time or hard starting, observe the pressure reading right after shutting off the engine. There should not be a rapid fuel pressure drop immediately after shutoff. If the pressure drops fast, the internal possibilities are check valve in the fuel pump not seating, leaking injectors, pressure regulator not closing, or an external leak such as fuel hoses and lines before the regulator. First, inspect the lines for leaks. If none, pinch off the return line and recheck key off fuel pressure to see if it now holds. If it does, the regulator is the issue. If not, then remove the fuel rail and injectors together and check for leaking by turning the ignition switch to on. You can also check for leaky injectors by pinching off both the fuel inlet and return lines and then monitoring fuel pressure. If the injectors are okay, the fuel pump check valve is the issue, and the pump will need to be replaced. Note that the check valve is an integral part of the fuel pump and cannot be separately replaced. High fuel pressure can be a result of a faulty regulator or a restriction in the return line after the regulator. Check the vacuum hose to the regulator first. If it is disconnected or blocked from manifold vacuum, the pressure will be high. If it's not a vacuum hose issue or the return line blocked, then the regulator needs to be replaced. If you see fuel in the vacuum line, the pressure regulator diaphragm is leaking and needs to be replaced. In the Fuel System Introduction module, you learned how the fuel injectors and fuel pump work hydraulically. In this module, you'll learn how these components work electrically. Like other electrical components on the vehicle, the fuel pump and injectors require power to operate. But they don't just operate all the time. Instead, they are controlled by the ECM-PCM through relays to operate at the correct time. Remember that a relay is an electromagnetic switch with two sides, power and control. The ECM-PCM operates the control side of the relay to provide a power path to the fuel injectors and fuel pump. Fuel injectors are basically on-off solenoid valves that spray fuel into the intake port of the cylinder. The fuel injectors require power and ground to operate. Power to the injectors comes through the PGM-FI main relay, which is energized whenever the ignition switch is turned on. The ECM-PCM provides the injectors with a ground path. This is also how it turns the injectors on and off. When there is no ground, the injector is closed and is not spraying fuel. When there is a ground, the injector is open and is spraying fuel. The longer the ground is on, the longer the injector is open, and the more fuel that enters the combustion chamber. The ECM-PCM uses various inputs to calculate exactly when grounding, injector opening time, should begin, and how long it should last. The opening time is called injector duration and is measured in milliseconds or thousandths of a second. You can observe injector duration with a DMM or on a scan tool. Before you can view injector duration with a DMM, you first need to figure out which wires to back probe. Look in the ETM and see which two wires go to each injector. One wire provides power, and the other ground or control. Carefully back probe the wire with the red lead. Then connect the black lead to chassis ground. Set up the multimeter to read injector duration. To view injector duration on a scan tool, first plug in the tool and then enter the vehicle information. Open the PGM-FI menu and the data list. Duration will change based on engine loads and operating conditions. Injector duration is shown here with the engine at idle, transmission in park, and all electrical loads off. When air conditioning and other loads are placed on the engine, the ECM-PCM will increase injector duration to compensate. If the ECM-PCM did not do this, engine idle speed would drop under these added loads. When a vehicle decelerates with a closed throttle, the ECM-PCM turns the fuel injectors off to save fuel. It turns the injectors back on right before the engine reaches idle speed. This function is called fuel cut and is normal. Fuel cutoff also occurs when engine speed gets too high, regardless of the throttle position. It does this to protect the engine from over-revving. Some older models may have injector resistor assemblies. Power flows through the resistors before going to the injectors. The injectors on these vehicles are designed to operate on reduced voltage. Newer vehicles do not contain separate resistor assemblies. Instead, the injectors have higher internal resistance. The fuel pump's job is to pressurize the fuel system for engine starting and then continue providing fuel for the injectors while the engine is running. The PGM-FI main relay also supplies power to the fuel pump relay. When you turn on the ignition switch, the ECM-PCM activates the pump relay for 2 seconds to turn the pump on and pressurize the system. If it does not see the engine running, it will turn off the relay and stop the fuel pump. If the ECM-PCM does see the engine running, it will keep the fuel pump running continuously. Some vehicles have multi-speed fuel pumps, which offer more precise control of the fuel supply. In the older type, the ECM-PCM varies pump speed by applying either low or high voltage to the pump, depending on engine fuel requirements. When less fuel is needed, the ECM-PCM deactivates the fuel pump relay, and current goes through the fuel pump resistor to lower the output of the pump. When fuel demands increase, the ECM-PCM activates the fuel pump relay so that current can bypass the resistor and go directly to the pump to increase output. Newer vehicles have a separate fuel pump control unit that changes fuel pump speed with driving conditions. The fuel pump will operate in 3 modes: low, mid, and high. When engine speed and load are low, the fuel pump receives 9 volts. Then as engine speed and load increase, the voltage will increase to 10 volts, and then battery voltage under heavy load and high engine speed. There are several ways to test fuel injectors, such as when diagnosing a no-start or misfire condition. A NOID light offers you a quick way of seeing the electrical side of a fuel injector in action. To do this, disconnect one of the injector connectors and plug in the NOID light. When the engine is cranking or running, the light will flash each time the ECM-PCM energizes the injector. The time the light is on is the time the injector would have been spraying fuel. If the NOID light does not illuminate and flash, there could be an open in either the power or ground sides of the injector circuit. A light that flashes dimly indicates unwanted resistance in the power or ground circuit. If the light is constantly on without flashing, there is a short to ground on the control side of the circuit. A properly operating injector should make a clicking sound when the engine is running. You can listen to it with an automotive stethoscope. This can be helpful in verifying the injectors are opening and closing. If you hear the injectors opening and closing, there can still be a fuel flow blockage or a problem with the spray pattern. A cylinder balance test can help you in identifying which cylinder may not be getting the proper fuel. To test the resistors, follow the steps listed in service information. In this example, you first disconnect the injector resistor connector. Then check the resistance between each of the injector resistor terminals and the power terminal. The resistance value should be between 5 and 7 ohms. If any of the resistance readings are outside the specification, replace the resistor assembly. When you first turn the ignition switch on without starting the engine, you'll hear the pump run for 2 seconds and then turn off. You may need to unscrew the fuel fill cap and listen to hear it. Some vehicles allow you to turn on the fuel pump manually with the scan tool, which can be helpful in isolating fuel system problems.